of math people to give us more problems like that, but here we go. We got another problem with unlike denominators. That's okay, because we still know the process. I mean, it takes longer, right? It's just, but it's still work that we know how to do, all right? So first up, let's go ahead and change the 4 3/8 into an improper fraction. So again, I wish I remembered to do this more often, but I like to kind of set this up first so I can kind of just fill in the blanks as we go, right? I know it's subtraction. I know I'm going to end up with 2 improper fractions, so no need for mixed numbers, right? And so I say, well, 4 times 8 in cycle method, that'd be 32. And then cycle up to the 3, that means we're going to add that 3 there. 2 plus 3 is 5, and just bring down the 3, makes that numerator 35. So I have now 35/8, but cycle method on the 3 1/3 as well. So 3 times 3, which is 9. And then cycle up to the 1 there, meaning we're going to add the 1 to make that 10. So that ends up being 10 in the numerator, 3 in the denominator. How did I know that's going to be 3 denominator? Because it just keeps the denominator that was with it already. So now I have 35/8 minus 10/3. So let's go ahead and use that method then. So I'll say we're going to take the 8 denominator and multiply it by 3. Now looking forward here, that's going to give me a new denominator of 24. Which means if we looked at the second denominator, it also should end up being 24, right? Now, I don't know that for sure, but we should find that it is the same. Before I look at that, though, let's multiply the 35 by 3 in the numerator as well. So that would be 35 times 3. I'll try to move that over a little bit. 35 times 3. 3 times 5 is 15. Carry the 1. 3 times 3 is 9, but add the 1 makes that 10. So that's 105/24. Now, I feel like I haven't said this in a long time, but if I have, please forgive me because, again, I don't feel like I can say this too often. We've taken this number, 35/8, and we changed the way it looks, but we did not change its value, just the same way that just going back here, just the same way that we did with 4 3/8. We changed the way that it looked into 35/8, but we actually did not change the value. That's kind of a key component in math. If you can figure out that you can change the way things look without changing the value, then you can, well, there's almost no limit in mathematics that you can do, all right? So we look at the 10/3, and I'd say, all right, got to multiply the 3 by 8, right? Well, 8 times 3 is 24. So that accomplishes this part of the objective, is to force the denominators to be the same. They are the same. But I need to multiply the 8 by the numerator as well, so that's 8 times 10, which is 80, right? Really, all I did was 8 times 1, which is 8, and then tack that 0 on the end. Seems like it was like that on that first problem. But, in any case, the denominators are the same, so we're going to keep it the same when we combine this into one fraction. We are subtracting here, but we're going to take 105 and subtract 80. Right, so let's see what we get from that. 105 minus 80. Yeah, I'm trying to color code these. I hope it's at least kind of helpful. 5 minus 0 is 5. 0 minus 8, I'd make that 10 minus 8, which is just 2. So that gives us 25 as our new numerator. Denominator, of course, stays the same as 24, but new numerator of 25. So now I have 25/24, and these are pretty close together, so I wouldn't anticipate that they could be simplified. Of course, 25 is divisible by only 5, whereas 24 is not. So that kind of solves that part of it for us. So I'm going to change this now into a mixed number. Right? We got the whole value here. The denominator is not going to change, so it'll still be in 24ths. And yes, some of you can do this in your head. Some of you cannot, and that's okay as well. So I'm going to show this using long division. So those of you that can do it in your head, just be careful because we tend to make more mistakes than we would like sometimes. At least I do. I'm talking about myself, of course, when I do things in my head. So 24 won't go into 2, but it will go into 25. I'm not even going to show the multiples for this because it only goes into 25 once. 1 times 24 is, well, 24. When I subtract that, it'll give me the remainder of 1. 5 minus 4 is 1. So the quotient there is 1, so that's my whole value. The remainder is 1, so that's the numerator of the fraction. And it looks like that 1 over 24 cannot be simplified. So that just is our final answer there, 1 and 1/24. Now, something that you should have noticed on this one is that there was no need for simplification at this point, whereas that first problem that we did, there was a need for some simplification at this point. It just varies. Sometimes you'll use this method and you do need to simplify the improper fraction, but like we see in this one, sometimes you won't, which is actually one of the reasons why I like this method of forcing the denominators to be the same, because there's always a possibility that you may not need to simplify in the end, and you would see as well if you made a list of multiples of 8 and 3 that 24 was the lowest common multiple of the two. So and again, I almost feel like I've hit the jackpot when I've done that, but it won't always come out that way. So do be careful.